Hello students, welcome to YouTube channel Vidya for Success. Dear students, in this video, let us study the concept of histogram. Dear students, let us study what are the different methods of representing the graphs. So when are we going to consider graphs instead of diagrams when there has been frequency given? Okay, nothing but when we are having frequency distribution, then we will choose graphs instead of diagrams. So there are different methods of presenting a frequency distribution in the form of graphs. The different methods are, the first one is histogram, followed by frequency polygon, and third one is frequency curve, and the fourth one is ogives. So these are the four methods which you can choose to represent a frequency distribution. Okay, so if the data is having frequency, then it needs to be represented. It cannot be represented via diagram. It can only be represented via graphs. So let us study in detail how to construct a histogram. So histogram. So what is a histogram? So histogram is constructed only for continuous frequency distribution. This is very important. So if you have been presented with a discrete frequency distribution, then you cannot construct. It is a difficult task. But when we are having a continuous frequency distribution, then we can easily plot a histogram. So what is the definition, official definition of histogram? So a histogram is a set of adjacent rectangles. Nothing but rectangles are placed next to each other without leaving any gap or any space. Okay, so what is a histogram? Histogram is set of adjacent rectangles. What about their height and width of each rectangle? Whose height and width are proportional to class frequency and the width of the class respectively. Nothing but the height of each rectangle is proportional to class frequency. For example, let us say we are having a class 10 to 20. Corresponding to that class, we are maybe having the frequency 5. So what is the height of the rectangular bar? The height is equal to 5. Okay, so the height, how you are going to measure the height of each rectangular bar, which can be considered by going through the class frequency. So the height is proportional to class frequency and the width of the rectangle is directly proportional to the class. What is the width? For example, the width of the class 0 to 10, the width is 10. For what is the width of the class 10 to 30, the width is 20. So each rectangular bar will be erected considering height as well as width. But when we started with the bar diagram, then all the rectangles were of equal width. We were not considering width different for each rectangular bar. But now in histogram, there may be a change in the width of each rectangular bar. It all depends upon the class width. So that's why a rectangular bar, how are you going to construct? Its height will be proportional to the class frequency and width will be proportional to the class width. Such that how we will be constructing? So the complete all these rectangular bars after erected, such that the area of all the histogram is proportional to the total frequency. In a histogram, we may be constructing, we may be erecting 5 or 10, let us say, rectangular bars. Okay, so the entire area coming under the rectangular bar will be proportional to the total frequency. Okay, so once again I will read out the complete definition. What is histogram? A histogram is a set of adjacent rectangles whose height and width are proportional to class frequency and the width of the class respectively, such that the area of the histogram is proportional to the total frequency. Now let us understand another concept regarding the pictorial representation. So in x-axis what we are considering and y-axis what we are considering. Okay, because these are all two-dimensional diagrams. Okay, again histogram is a graphical representation of frequency distribution. Here we are going to consider two-dimension x-axis and y-axis. So what is the x-axis representing? What is the y-axis representing? Here the various class limits are taken along the x-axis. Please notice here the x-axis is representing the class limits. For example, 0 to 10, 10 to 20, 20 to 30, like that. Okay, so here the x-axis are nothing but they are representing the class limits. The various class limits are taken along the x-axis and corresponding to each class there will be a frequency. So frequency will be taken along the y-axis. In my class, let us say there are 15 or 20 students have scored, 20 students have scored marks between 10 to 15. Let us say in my class there are 25 students, they have scored marks between 15 to 20. Okay, so on the x-axis in the histogram, we will be considering only the class limits, the thing, class intervals. But in the y-axis, we will be considering the frequencies. This is how we are going to plot the histogram. Next, in case while constructing the histogram, let us say that we need to consider a class interval which is inclusive in nature. Okay, so what do you mean by inclusive class interval? Let us please notice here. Here we are having an inclusive class interval 1 to 10. Next is 10, 11 to 20. Next is 21 to 30. Nothing but both lower limit and upper limit of the class limits, they are included in the same class. Please notice here 11 to 20 is one class. Okay, both lower limit, that is 11, as well as upper limit 20, they are included in the same class interval. If we have been presented with such a class interval and we have been asked to plot a histogram, so our duty is to convert these inclusive class intervals to exclusive class interval. So if we convert them, for example here, 1 to 10, it will be 0.50 to 10.50. Nothing but we will be subtracting 0.5 from the lower limit. Similarly, we will be adding 0.5 to the upper limit. Okay, so this is nothing but the way to convert an inclusive class interval to an exclusive class interval. So while constructing histogram, inclusive class intervals should be converted into exclusive classes. If you won't convert this, then there will be clash of these rectangular bars, because the rectangular bars will overlap. That's a problem. Okay, next, followed by that, the next thing is how, in case there is a change in the class width, then how we are going to construct a particular histogram. As we have said that the width of each rectangular bar is directly proportional to the class width. So that's why if the class intervals of unequal width are given, then histogram is constructed by frequency density. Please notice here. So here there is a class interval 0 to 10. What is the width? 10. 10 to 15, what is the width? 5. 15 to 20, what is the width? 5. Next, 20 to 40, what is the width now? 20. 40 to 50, what is the width? 10. So there are different class widths. So if such a class interval is given, then we cannot construct a histogram by considering the frequencies. Nothing but each rectangular bar height cannot be considered, or else width cannot be just you cannot consider the width by going through this frequencies. So at that moment you need to consider frequency density. Okay, so you cannot go with ordinary frequencies, then you may have to consider a new concept called as frequency density. What is frequency density? Very simple, frequency of the class divided by width of the class. For example, here frequency is 13, 13 divided by width is 5, 13 divided by 5 will get a value. What is frequency density? Frequency of the class divided by width of the class. So if the class intervals of unequal width are given, then histogram is constructed for frequency density against the width of the class interval. Nothing but how you are going to consider the height of each rectangular bar. Height will be considered against the frequency density, not against frequency. And what about the width of each rectangular bars? Width will be proportional to the class width. Here it is 5, here it is 10, here it is 5, again 20, here again 10. So width will change. Okay, nothing but each rectangular bar will be of different width. Maybe some of them will be look slimmer, some of them will be look little bit heftier. Okay, so this is how we are going to construct a histogram if the class intervals are unequal, then only. Okay, form histogram in case if you want to construct, if you want to find mode. Okay, so from the histogram, mode can be obtained. How can we obtain the mode? What is mode? That we will be discussing in the later chapters, but mode is nothing but the highest frequency. For example, in my class, I have conducted an exam for 50 marks, let us say. Okay, for overall 100 marks, let us say. There are the 60 or 70 odd students who have taken the exam. So, which is the highest score I want to know? So maybe the highest score is, let us say, 85. So that is the mode. The highest value in the frequency distribution is called as mode. Okay, if you want to know that mode, if you want to find out that mode using histogram, is it possible? Yes, of course it is possible. How to obtain it? There is a very simple way. That is, from the histogram, mode can be obtained by joining the upper vertices of the tallest rectangle to their opposite upper vertices of the rectangles adjacent to it. So, how to obtain the mode? So, first of all, we need to identify which is the tallest rectangle. So, here in this example, this is the tallest example, that is the 30 to 40 class interval. So, this is the 25, frequency 25, this is the tallest rectangle. So, here there are two vertices. See here, okay. So, from the upper vertices, we need to draw a line diagonally meeting the opposite upper vertices of other adjacent rectangles. So, these are the adjacent rectangles. So, from this vertex we will be drawing a line the opposite to the opposite upper vertices, similarly like this. After drawing line to the opposite vertices, we will be getting an intersection point. So, from this intersection point, then from this intersection point, if we draw a line perpendicular to the x-axis, the meeting point in the x-axis will identify what is the mode. That's all, very simple. Okay, so from the histogram, mode Z, always mode is indicated with capital Z. Z can be obtained by joining the upper vertices of the tallest rectangle to their opposite vertices of the rectangles adjacent to it. Then from the point of intersection of these diagonals, draw a line perpendicular to the x-axis. The point at which the perpendicular line touches the x-axis gives the value of mode. Very simple. Okay, so this is how you are going to find mode via histogram. So in this video, we have studied what are the different forms of graphs. There are 4 different forms of graphs: histogram, frequency polygon, frequency curve, and ogives. And we have detailedly studied how to create or construct a histogram. Thank you.